Good morning everyone, it's me Arjun Pokhrel. I'd like to welcome all my dear students in my online class. Today I am going to teach another topic of class 10 from the fourth chapter, that is acceleration due to gravity. First of all, what do you mean by acceleration? We already discussed about acceleration in the lower class. The rate of change in velocity per unit time is called acceleration. The rate of change in velocity per unit time is called acceleration. What do you mean by velocity? Distance traveled by body per unit time. That is called velocity. Rate of change in velocity per unit time is called acceleration. If the acceleration is created due to gravity, then it is called acceleration due to gravity. Okay, the acceleration produced on the freely falling body due to the effect of gravity is called acceleration due to gravity. The acceleration produced on the freely falling body due to the effect of gravity. Gravity is also one of the force. Due to this force, the object which is falling towards the earth, okay, its velocity increases in every second. Okay, this is called what? Acceleration. What is the SI unit of acceleration? SI unit of acceleration is what? Meter per second square. It is denoted by small g. Acceleration due to gravity is denoted by small g. SI unit of acceleration and SI unit of acceleration due to gravity, that is what? Same. Its value is not constant. Its value changes from one body to another body. Okay, its SI unit is meter per second square. SI unit is what? Meter per second square. The acceleration due to gravity of the earth is 9.8 meter per second square. Meter per second and divide by second. The acceleration due to gravity of the earth is 9.8 meter per second. Okay. One question. The acceleration due to gravity of the earth is 9.8 meter per second square. What does it mean? Okay. The acceleration due to gravity of the earth is 9.8 meter per second square. What does it mean? Okay. Write down. It means the velocity of the freely falling object towards the earth. Okay, the velocity of any freely falling object. Okay, if the falling object is not obstructed by any air or any other resistance, then the velocity of the freely falling object towards the earth is increased by 9.8 meter per second in every second. It means in every second the velocity of the body is increased by 9.8 meter per second. Okay. In the given diagram, the velocity of the body in the first second is 9.8 meter per second. Okay. The apple in this diagram, the apple is falling towards the earth. In the first second, the distance traveled by the apple is 9.8 meter. Okay, in the first second, the distance traveled by the apple is only what? 9.8 meter. In the second, the distance traveled by the apple is what? 19.6 meter. Because in the second, the velocity of the freely falling body is increased by 9.8 meter per second. That's what we have to add. 9.8 plus 9.8, that is what? 19.6 meter distance traveled by the body in the second. Okay, it means in the second the velocity of the body becomes 19.6 meter per second. And likewise in the third second, the distance traveled by the body is what? 29.4 meter. Okay, and so on. It is because of the acceleration. Understand? According to Italian scientist Galileo Galilei, iron balls of different masses are released simultaneously from the top of Leaning Tower of Pisa. 2 iron balls are released from this tower. Okay, from the top of this tower, 2 iron balls are released at the same time, simultaneously. Okay, then what will happen? All these balls reached at the ground. Okay, all these balls reached at the ground simultaneously. That all the bodies of different masses fall with the same acceleration. Okay, if air resistance is excluded. If air resistance is not included, then after all the balls, okay, all the bodies, all the objects, okay, falling from the top of this tower, Pisa tower, okay, fall on the same time. It is because acceleration due to gravity, does not depend on the mass of the falling body. Okay, acceleration due to gravity what? Does not depend on the mass of the falling body. From this we can easily say that 2 bodies, one heavier, okay, suppose the mass of one body maybe 20 kg and mass of another body maybe what? 5 kg. Okay, both balls are released from the top of the tower. Okay, what will happen? Both ball falls on the ground at the same time. Okay, both balls falls on the ground at the what? Same time. It is because acceleration due to gravity does not depend on the mass of falling body. Okay, acceleration due to gravity does not depend on mass of falling body. If what? Or the lighter fall freely at the same rate if air resistance is excluded. That is, they have the same acceleration as the acceleration due to gravity of the earth. Galileo had done an experiment to demonstrate it in 1590 AD. Okay, Galileo, one of the famous Italian scientists, had done this experiment in 1590 AD. Okay, another one experiment to prove that acceleration due to gravity is independent to the mass of the falling body, that is Quine and Feather experiment. This experiment is also known as Guiana or Quine of England. Okay, Guiana or Quine of England and Feather experiment. This experiment is also known as Guiana or Quine of England and Feather experiment. This is the famous experiment. Okay, this is what? Famous experiment which absolutely proves Galileo's idea. Okay, I already told you what is the Galileo's idea, and this experiment, experimentally proves, absolutely proves the Galileo's idea. Okay, now I am going to discuss about that Quine and Feather experiment. In this experiment, a tube is taken and Quine and Feather are kept inside it. Okay, this yellow tube shown in the diagram, this tube is taken and both this feather and this what? Quine. This Quine and Feather are inserted, are kept inside this yellow tube. Then the 2 ends of the tube are what? Closed. Both ends of the tube are closed. This end and this end. Both ends of the tube are what? Closed. The tube is inverted quickly. Okay, then the tube is what? Inverted quickly. It should make a upside down. Then the result is that, okay, the result is that what? Coin reaches the bottom earlier than the feather. Okay, coin reaches the bottom earlier than the feather. Okay, once again listen carefully. First of all, a small tube is taken, then after coin and feather are inserted inside the tube. Okay, then after the tube is inverted quickly. First both ends of the tube are closed, then the tube is inverted quickly. Okay, the result is that coin reaches the bottom earlier than the feather. Okay, this small coin reaches the bottom earlier than the feather. Okay, and same experiment. Okay, in the same experiment, this is because air present inside the tube resists the feather. Okay, this is because what? Inside the tube there is what? Air. Due to this air, the feather falls on the ground slowly because of the upthrust created by what? Air. Resistance created by air. When the air is taken out of the tube and this tube is inverted, okay, when we do the same experiment, okay, by taking out air from the tube, and we have to make vacuum inside the tube, okay, and if we do the same experiment, then after what will happen? Both coin and feather, okay, both coin and feather fall on the ground simultaneously, okay, at the same time. Okay, what conclusion can be drawn from this experiment? If there is no air resistance, okay, okay, thank you for watching. Next class, force part 4. Thank you.